Cool. And we are live. Hello, everybody. Welcome back as we continue to go through Basic Electronics, the workbook number 1 from our good old-fashioned RadioShack kit. This is now part 3 of an ongoing series. You are joined by myself, Shigi, and one of my best and oldest friends, Crow.
What's up?
All right, cool.
Excellent.
All right. What? What'd you say?
Excellent.
Excellent. Most excellent, my dude.
Definitely.
All right. We left off. We'd finished this massive board with all these wires, and we have capacitors and resistors connected, and another resistor connected, and an insane amount of wires. And if we turn this bad boy on and we kick this down, we get our little tune. Although you did observe before we started recording that there is a weird... Why are we not getting anything else from like the mid position? Because this does have a mid position if it goes soft. So that's a good point. All right, well, let's turn this off and let's pick up back where we actually were on the last one. So I believe...
We had just done the resistor tests. We did not have the capacitor for the tests. Still waiting on parts.
That's right. Bummer. Okay, so we're test the circuit. We did that. We did the resistor test. That's where we left off.
That is correct.
Okay, and we don't have the capacitor.
That
Understood. All right, cool. Yeah, we did order some more capacitors and things like that. And hopefully that should be here sometime this week. Cool. All right, well, let's pick up on the next piece here. Switches and how to use them. Your electronics learning lab has 2 slide switches and 4 push button switches. You will learn how to use each kind of these switches. So that's got to be these guys right here, right?
Excellent.
The push buttons, and then what were the other one? And 4, 2 slide switches. So I'm assuming it's this guy. Is there another slide switch somewhere?
Might be one of, no, those are dials.
I don't see another slide switch. Maybe they're talking about the on-off.
Oh, yeah, maybe.
That'd be kind of weird.
That
Okay.
would be.
All right, cool. So let's do using the main power switch. All right, push the power switch to off. For very first thing.
Power switch is off.
Switch is off. All right, we're going to connect spring. Oh, okay, so we're going to need some wires. We're going to connect spring 666.
Absolutely.
I'm just kidding, it's 66. Spring 66 to V2, and that's going to be the 3 volt.
And that's 3 volt, and that's a blue wire. And you said 666.
666.
Over here. So we're going to go ahead and use a longer blue. You said 3 volt?
Yes, sir. We're going to 3V.
Gotta put that in the first.
So volt, or no, I'm sorry, volt to V2, 3 volt.
Oh,
Yes, okay,
V2.
we're V2,
Okay.
3 volt.
V2.
We
Got
got
it.
it. All right. And we're going to connect spring 67 to the ground.
Okay, we have 6-7 is not ground.
That's going to be the spring guy. And we're going to go to the ground.
So we're going to attach another cord to this one. So remember last time they told us not to mess with this. We're going to be using this.
Yeah, it did say that, right? It said don't take it apart.
Do not take it apart. And you said to the ground. Any ground, right?
I believe any ground would work, but in this case, let's just go to the, yeah, it just says any ground.
All right, we're going to stick it to the closest one.
Should good. All right, go ahead, turn on.
Ooh,
Oh, there's our beep.
I like it. Our DP-DT switch does not work.
Interesting. Okay.
Stands for double pole, double throw. Double pole, double throw. Holy moly.
All right. Let's see. This simple demonstration shows how the power switch controls power to the breadboard. Push the power switch on and the buzzer will sound. Yep, we nailed it. Okay, now we're going to use the DP-DT switch to actuate?
Actuate the buzzer.
It is actuate, right?
Actuate, for sure.
Why do I feel like the way that we pronounce it, there should be an H in it? Actuate?
It should be like actuate.
Actuate.
Actuate. Like, so like
Actuate? Actuate.
actuate.
This is that This is that New Yorker accent coming in, just putting in extra.
It's like actual.
Actual. Oh yeah,
Actual.
actual. Yeah.
Yep.
Wait. Yeah, there's no H in actual.
No.
Oh man, we're done.
Absolutely.
This is why we get made fun of wherever we go. All right, switch to off. We're good.
We are off.
We're going to connect spring 43 and 66.
Okay.
And you're going to use a blue wire for it.
Blue wire, 43 and 66. Are we coming?
I think we could pull the rest of that stuff off, though.
Yeah.
Yeah, let's pull off the 2 that we just did.
Okay.
Or you can keep that 66 on there. Cause it's already,
so.
Yeah.
Yeah.
So 66 to 40, spring 43.
4-3. We right through here because I like to make spaghetti. Let's go. Oh, no, that's messing with that resistor. We're not touching that. We're going to come through the other way.
I'm wondering if they're thinking that we should be using something else. Should we be using something else? Should we go get another one of these breadboards?
I'm not certain. I think that they want us on here. I'm not sure.
All right.
Gotta get this resistor back in now.
Yeah, we're building so many different things. I know that it said not to mess with it, but we... Oh, dude, we're just going to be building a bunch of weird things here.
Okay.
I think we should just get another board.
So we're now on 6-7. Well, yeah, I know we were trying to maybe make a breakout sort of board and maybe test it across this.
Do you want to get a
At
different
one
board?
point.
We got another board. We got another one
It's
of
in
these.
here, right?
No, we got another one of these kits.
Oh, yes.
Should I just go get another kit and then we test it? That way we could separate them from our existing one. And we
Well, I
just
know
put
it
back together.
assumes that we're going to be still using this thing.
Right, so that way we can set that one off to the side. We do the other one for just these little ones. That way people that are watching can follow along when they don't have all the other stuff.
I guess so. Let's see, what do they want us to do?
All right, while you look that over, I'm going to get another one just in case.
That's a good idea. Better to have and not need.
Oh, you got it. Nice job, dude.
And for all of you guys watching at home, we are still working off the RadioShack Basic Electronics book, the Workbook 1. It has been an interesting experience. Been teaching us a lot about electronics, about troubleshooting, for sure. And I recommend it highly. For everybody else who just wants a few references, we have a reference page here. A terms page here. Of course, our glossary of
What does it look
parts. Just giving an overview of the components. Again,
I think we're good. Let me just make sure that we got the right batteries in this guy.
so it does tell us in the book that we are going to be building these on top of this, and we're going to be using this circuit to test whether or not these new circuits work.
Oh, well then I just went and found a bunch of batteries and this board for nothing. But we have another board in case we want to build something separately.
Hey, and again, if we would like to show a little bit more clarity on what we are currently doing, you know, we could always show the second board. For sure. It's a good
Cool.
idea.
Yeah, it's a good point. It's a good point. All right, cool.
All right.
So we are good to go then. All right. Well, let's pick up where we left off. My fault.
All right, that's not a big deal. I just connected 6, 6 to 4, 3.
Awesome. Cool. All right, we're on part 2. This is for the DPDT switch. All right, we're going to connect spring 44 to V2, so the 3 volt.
Okie doke.
The
So
blue wire.
I'm taking this guy out. 44 to
V2.
V2. Let's go ahead and connect it there. 4 here. This is where we get to troubleshoot our middle. That's we're going to readjust. There you go.
All right. And then finally, we're going to connect spring 67 to the ground, blue wire. The one that you literally just undid, we got to redo.
Excellent, excellent. So yeah, this is how we this is how it operates.
Is that gonna reach?
Exactly. We're hoping for the best.
I don't think that's going to reach, brother. Maybe we just... Oh!
6, 7.
Yes, sir. This...
6, 7 for all you at home. We have Gen Office. Let's
Why was that making noise?
Well, I'm not sure. We are off.
Yeah.
I'm gonna go ahead and snag this long green. We're going to use this in place of blue for this particular purpose.
I'm worried because that's off.
That thing is off. We are overwriting the command structure of this machine here. There we go.
Oh, that's probably not a good sign.
Let's flick this.
Okay, there we go.
Excellent.
Why was it
So-
making noise
So
when
we're
it was off?
discharging somewhere.
This is gonna catch fire, dude.
Want to turn it on?
Oh, we didn't grab a fire extinguisher again. Oh, it's fine. We got one in the
It's in
kitchen.
the kitchen.
Yeah, it's in the kitchen. Okay, cool. All right. Well, the circuit uses 1/4 of the DPDT slide switch to control the buzzer. Push this power switch on, and then push the DPDT switch up to sound the buzzer. So you already got it up. So if you turn it on, wow,
Now that is a high frequency.
that's loud.
Let's turn this.
Oh,
Now it's a low frequency. Maybe not too low.
is it because of the resistor that's in there? Maybe.
That's kind of what I'm wondering. What do we? It's interesting how this board operates.
Yeah.
Honestly.
All right. You ready to do 3?
Sure. Yeah.
All right, we're gonna swap it to a push button.
So we're gonna go ahead and remove what we had just done.
Wait! Before you do that, because
Okay.
something tells me we're going back to them.
Let's take a peek.
47 to 66. Wait, we got the power off. Number 1, right?
Power is off, and that is correct. That is the first step all of the time. Do not forget.
Okay. 47 to 66. So take it out of 43.
43.
Take it out of that end and put it into 47.
Okie dokie.
So I'm assuming that's taking out the DPDT switch and then putting it into the press button, right? Probably.
Yes, it looks like that's where it's going into, for sure. Hope it doesn't scream at us again.
No, because it's going into a push button this time.
Okay.
But also it was off last time.
You know what this reminds me of? You ever go to those dentist's office and they have that wood structure with all the little pieces on it? With all the wires that...
Oh,
you push the
yeah.
pieces across them? Yeah. That's exactly
It does
what this
look
looks
like it. Man, you're bringing back this book and this kit, and then now you just brought back like full childhood.
Yeah,
Where
there
you're
it
just
is.
sitting there traumatized.
Just-
No, you hear the drills going in the background.
Oh.
You're just moving the piece along the wire. You're like, oh my god.
Occupy my mind. Occupy my mind.
All right. Next thing we're gonna do. So we have 46 to V2. So
Okay.
basically take the blue wire out of 44. The one that goes from V2 to 44 on the previous one.
Got it.
And we're going to put that into 46.
Excellent. This is pretty cool because it's very highly adaptable. Pretty much just reusing the parts and rerunning the circuits.
And it's the same 4 as last time, 67 to ground, so we're good to go. All right, this circuit uses a push button switch to control the buzzer. Push the power switch up, and then press S1 to sound the buzzer. S1.
There we go. Let's see if it does the same thing as last time.
No, because it's not part of the DPDT switch.
Absolutely.
Huh. Oh, I got it right too. DPDD. DT.
No, there it is.
DPDT.
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 That was a tough one to say. I will never be able to say that thing quickly.
You know what I'm noticing here? Look at the symbols.
switch.
You can identify the switch, right? So this is the DPDT switch right here, right? And it looks like it's kind of like the equivalent, like if you ever see an open door. And then, but the push button, it's just got like it dead ends, and then there's a flat line over it. So that's the button.
It's like the metal plate that crosses.
Like a metal plate.
Yes.
Yeah. Okay. Cool. Well, now we should be able to recognize that going forward.
Excellent.
I wonder if we're gonna get to a point where we could just see this and just go, "Oh, cool. Yeah, no worries."
Yeah, I'm thinking that's what they're suggesting.
We'll see.
Absolutely.
We'll see. It could just not be, and it'd be like.
Well, I mean, let's see. Well, actually, let's see. Well, give ourselves a little challenge.
What do you
See
mean?
if we can build this one without looking at the text.
But there's no. Oh yeah. So there's numbers underneath. We'll do this.
It's a DPDT switch and the push button. We're gonna still need the numbers, but let's see if we can figure this out.
All right.
We have reference for them
So
above.
basically, we're taking a 3-volt into the DPDT, right? And then we're going to run the DPDT to the push button, and then the push button to the actual speaker down to ground.
Okay.
If I'm reading this right.
So we'll start with the 3-volt, and let me take
3-volt to 44.
I
It's
see.
the same deal.
3-volt to 44. Okay, so we're gonna take that out of here. We're gonna put that into 4 right back in the center.
Oh wait, push the power switch off. Okay, good.
Power
Yeah,
switch is off.
You
Yes.
did. All right.
But it is an extraordinarily important step.
All right. Then we're gonna go from 43 to 46.
Okay, so we're gonna snag
That's got to be on the DPDT, right? Or no, that's just a
That's
straight
the
wire to
push-
the
that's the
switch
push
to the
button.
button. Yeah.
so 4-3 to 4-6.
Yep.
Now we'll try not to knock out the resistor this time. Pretty little corkscrew on this.
Oh, you know what's gonna really? I cheated. I looked
this?
over. We literally could have just done 2 things.
What's that?
Move the blue wire at V2 to spring 43, and then connect spring 44 to V2.
Amazing.
That would have been the end of it.
And then we would be done. Well, here we are now.
All right. So we went 43 to 46, right?
We are now 43 to 46. That's correct.
Okay. So we're going then on the other end, 47 to the buzzer, 66.
47 to 66 is still active.
Okay, and then 67 to ground.
6-7 to the ground.
Cool. All right.
Okey-doke.
So let's see. Off the 2 or more switches are wired together. This circuit actuates the buzzer when the main power switch, the power button, and the DPDT slide are closed. So when they're closed. Okay.
Okay.
So turn it on.
So we're going to turn this on.
Yep.
That switch is in the down position.
Okay. Press the button.
And we have a noise.
All right. Turn.
To the up position.
We have a noise.
There's another noise.
Yeah, I think the reason why we have a noise is because we still have that giant monstrosity that we put together the last time, and it's still running active. We have power running through it, right? I mean, actually, you know what? Let's kill the power going to it.
Well, we're supposed to be using that to test our circuits.
But we have it, though.
Well, I mean, if we look. Well, I mean, we're still. Yeah, you're correct.
Out of curiosity, pull the 3-volt. Where's the one that we just ran?
This is the one we
Okay.
just read.
Pull the other one out. Keep that one in.
Keep that one in.
Pull the other one out so there's no power running through that piece of the board. We now just have an isolated circuit all with the blue wires and one green one. So I bet you anything it works.
Yeah, but you hear how much
Now turn it
slower
down.
does?
Ah, see? See, that other one's our test.
Oh, you are correct. Okay, so we can plug this one in when we are going to use it.
Yeah. So, like, if you ran it now, you're on, by the way.
Oh, gosh.
No, you're good. No, turn it on, turn it on.
Now I'm turning it on.
Yep.
I need to turn it off.
That's our normal one.
And our normal and our...
It's higher. It's more volts.
Well, yeah. Holy moly.
Yeah. Yeah.
Does it say what we're supposed to expect?
It just says when it's closed and you press the button, we should get a beep.
So
if you were to rip the red out, the power from that initial circuit that we built,
okay.
pull that, and now if you were to press the button, there you go.
That's interesting.
Makes sense. It makes sense because we're running two different circuits on top of each other simultaneously because we have two different power sources.
We definitely do. It's just interesting they tell us
To keep
this
it.
is how we're going to...
Yeah, they're like, keep it. And it's like, why though?
Right.
Could have just built on there. I bet you anything, as soon as we deviate from this plan, it's going to bite us in the ass. So let's just keep doing what we're doing here. All right, we finished this one. We kind of half did it ourselves. Sort of. All right, let's take a look.
That was pretty good, actually.
Yeah, it was good. It's fun. This is fun messing around with this. And we haven't set anything on fire, so that's my main victory for the day.
Yes, absolutely.
All right, swig of the beer, and then let's get back to it. All right, use the DPDT switch to actuate two devices at the different voltage. Oh, okay. So power switch off.
Power switch is off.
All right. We are going to connect spring 40 and 66. Now, do they want us to build this on top of the shit that we already have, or do they want us to take the other stuff out? I wish they would tell us.
So what it looks like is we are building the same consistent source. So we're probably starting from the same place.
Yeah, but it wants
we're
us to use the yellow wire.
We're just pushing these same wires into different
Yeah.
things. So I think you might be right. I think we everything that's coming from the buzzer is not going to be changed. Everything on this side of the board for all the manipulators, all the
it's probably
switches
going to be
are going to be what we're changing up. Yeah.
All right, so we're going to end new wire. We're going to grab the yellow wire.
Yellow wire.
And we're going to connect spring 40 and 66.
40 and 66. That is far away. We're going to use... I don't have a long orange. Here we are.
Should have some longer ones. Is that long?
Nope, that's a long
Let's
end.
see.
There's one right there, actually. I can see it.
You see it in there?
This guy.
Ah. Nice.
40?
We're going 40 and 66.
This says yellow wire, so there's already a blue wire in here. I'm going to go ahead and leave that. As we just discussed, I think we're... everything from the source is the same. Okie doke.
All right. Sorry, I was just checking chat real quick to see what's up.
That's A-okay.
Okay, we got some chat.
Excellent.
One says, hi, Steve. Who's Steve? No Steve
I have
here.
no idea who that dude is.
Steve. Okay. Let's see what else. Hi. Hi. Violet Zombie says, ouch. I don't know what we're ouching to. Did I get hurt? I might have got hurt. Might have been when we left it on.
Yeah.
That's probably what we did. Let's see what else. Cat to build or not to build. Yeah, exactly. And beep noises all day. Yeah, 100% beep noises. We're really good at the beep noises.
Absolutely.
Too many beep noises.
One of those right here.
One of what?
That's that thing, so you can look at it actively.
Oh, for the chat. That's genius. Yeah, we need to we'll get another monitor so we can have chat going.
Excellent.
That's smart. That's
We've
smart
attached a yellowish orange wire. Actually, I'm going to attach this orange one. I have some actual yellows.
Bam.
We're going to go ahead and use actual factual.
I did the smartest thing I could possibly muster up today, and I turned the monitor around so we could actually read the chat as it goes.
That's like that story about the guy in the boat and the coffee.
What's the story of the boat and the guy in coffee?
He wakes up in the morning and he sits there, and then he has the guys steer a big giant warship just a couple degrees so that the sun moves out of his face, in the morning while he's drinking his coffee, so he doesn't have to move his seat. It's an enjoyable story. You should check it out.
All right. After we finish this one, I want to hear more about the guy and his coffee.
Absolutely.
All right. So we just did 40 to 66. We're gonna do a blue wire. This is gonna be 41 to V6, so the 9-volt.
Okay. Blue wire next, 41 to V6.
You got it.
41 V6. Wow, man, they keep wanting me to traverse the entire board.
I know. I don't know how much of this we're supposed to be.
All right. Yeah, we're gonna find some VHS of some professional going over this entire thing, and we are going to learn a thing or two about not knowing a thing or two.
I can't wait till we have our first fire.
Excellent.
Actually, I'm glad I prepped the other board knowing that this is definitely going to happen. All right. Let's see. Spring 67 to ground, blue wire.
Blue wire, 6-7 to ground. All
Put
right.
that blue wire here.
Is that going to be long enough?
Yeah, it should be.
Oh, 6-7 to ground, actually.
We're already good.
There.
All right, sick. Okay. We're going to connect spring 43 and 12, blue wire.
4, 3, and 12 of the blue. Does it say we need a button on this one? It does not show us needing a button.
I don't see any buttons.
So I'm going to take the button away. Because 43 to what one again?
43 to 12. They're both springs. So that's got to go up to the top, I imagine. No, is it? Isn't it LED?
It is an
We're going to LED? Oh, yeah, LED one.
This
There we
purple
go.
one.
Didn't even mention anything about an LED in this. It's just kind of like... There's going to be a whole lot of trying to figure this shit out.
Two devices at different voltages.
I still don't think we're supposed to have that initial one on.
I don't know what they're trying to get us to do.
I think anybody trying to learn right now is screaming our names in just like the worst way possible.
Likely because they see me manhandling this piece of machinery here, and they're like, be delicate. Excellent. We are connected.
Okay. All right. That was 43 to 12. All right, we need a 44 to
4-4?
V2. Oh, we have two sources. Oh, yeah. We have a 9-volt and a 3-volt.
We have a 4-4 to V2 already.
You know what this is? The DPDT switch is basically going to route to either the LED or the buzzer with different voltage.
Oh, I see. Okay.
That's my prediction. We'll see if that's actually right.
11 ground.
Yep, we need 11 to ground. We did 44 to V2, right?
4-4 V2. Got it.
Okay, cool.
Boy, oh boy, this is a complicated machinery.
I think we're doing this. I think we are at fault for this. I think that we're not supposed to have any of those wires in the middle.
I think we do. They did tell us we're going to use this to test our connections. But I don't know. I don't know what they really want from us.
I know what
It's
they
a
want
mystery.
from us.
It's
They
like
want us to cuss a lot on the stream while trying to do
hieroglyphics.
this.
They did. Back then, they were like, these guys are going to cuss on a stream.
That's why we had to put in that high profanity.
Exactly. Well, back then they were already cussing, probably by streams.
All right, where are we at?
We
All right, we're
connected.
good. All right, push the power and DPT switches up to control 2 devices at a time. Oh, we control both of them. It didn't do shit.
It did not do anything.
It didn't do fucking shit. Sorry. All right. Let's rebuild this on the other board.
Excellent.
Yeah. All right, rebuilding time.
Okay.
It might be easier to follow. Bam.
We're going to go ahead and...
You're going to need all those wires
Still
again.
going to need these.
All right. I think we're good with the new board.
Do you want to...
Looks good to me.
Do you want to do the wiring up so you can...
Oh,
maybe
yeah,
make
yeah.
sure I'm not...
All right. So what I'm gonna do is I'm gonna pull it off of the board that we just did in that order, and I'm gonna replace them on the new board.
Excellent.
All right. So What do we
Because
got?
I'm starting to think you're right, but I don't know why they want us to leave that other
I
one
think
on
that
there.
like 6 different people drunkenly wrote that book, and that's why there's even like crossed out text in it.
So it's like that Home Depot book from back in the day. Yeah.
This is like trying to reverse engineer a engineering genius who just wakes up and chugs a beer before he goes and does your house wiring. I think that's what we're reading, and that's his notes.
Excellent,
You know what I mean?
excellent.
Yeah.
Yeah, he just woke up in the middle of a dream.
It just was like, I'm gonna fucking scribble this.
Oh yeah, I forgot. DPDT switch. Here you go.
I'm gonna just scribble this shit down real quick. All right, where are we at?
All right, so we
Power
need
off.
to push the power switch to off
It's off.
on both boards.
Off.
Connect springs 40 and 66 with a yellow wire.
40 and 66 with a yellow wire. That's 66. That's 40. Bam. We're going 40. Nailed it. 66. Nailed it. Good.
All right, our next step is to connect spring 41 to volt 6.
4-1 to V6.
It's the 9 volt. The
Got
blue wire.
We're doing green.
Yep.
You said it was 4-1?
4-1.
Done.
Excellent. Okay. Step 4. Connect spring 6-7 to ground. Blue wire.
6-7.
Yep, it's another green
Ground.
one.
It's another one of the green ones.
I
We're
like
going-
having our greens for that.
Yeah, that makes sense. 6-7, and we're going ground.
Absolutely.
Nailed it.
Connect springs 4-3 and 12 with a blue wire. I may have used the purple.
Did you use purple for that?
I may have used the purple, yeah.
You did. 4-3 and what? 12?
12.
Got you. We're going 12 and 43. This is way easier to follow, dude.
Yes.
All right, what else we got?
4-4 to V2. That's
V2.
our 3 volts. That's with a blue wire. Absolutely.
Blue wire to V2.
V2.
Victor 2 and
3 volts.
44. Got it.
Last and probably least, connect spring 11 to ground.
Got you. Spring 11
Complete the circuit. Least.
to ground. I'm gonna put the ground right next to where our other ground is.
Probably good to not just be throwing them everywhere.
All right. So
So now our next step is to push the power and DPDT switch up to control 2 devices at the same time. And what do we see?
oh shit. All right.
Rocking.
Well, DJ, bro.
Excellent.
And we got
Okay.
the LED. All right, let's turn that off before we deafen everybody that's listening right now.
All
Do
right.
we have anybody? We have 5 viewers right now. Oh, I am so sorry to everybody. Okay, cool. What else we got?
Well, all right. So I guess we're just going to go ahead and break that thing down, and just keep redoing it. And we're going to keep our control board.
Yeah, we definitely should keep
Bill.
our testing board for sure.
They-
So anybody that hasn't seen this is actually the board we built in 2. We're going to keep it because it mentioned previously that we should keep this one for testing all of our other stuff.
Yeah.
But then made us build stuff on top of it. So instead, so we don't get confused and accidentally mess up the existing board, we're going to just work off of this one for now until we need to start using the other one. At which point we could probably run from here to there as well, which would be fun.
That
'Cause
would
then-
be fun, actually.
Then we're using 2 boards.
That would be wicked cool.
All right, so I can pull this. I'll pull this all out. We'll go from there.
All right.
Bam.
We're gonna need probably
Start
a
fresh.
load of those blue and greens because we have a load of blue. Oh no, blue and whites.
Blue and
We have
whites.
a load of blues and whites coming up.
All right. I got some whites, got some blues.
How about we finish this next page and probably
I'm going to call it.
might be a good time for that.
What time is it?
Oh, that's almost 6.
Oh, all right. All right, let's go from here. Let's see where we're at.
Yeah, it's not that. It's actually we were able to do 1, 2, 3, 4, and 5 plus troubleshooting.
All right, let's knock out this next page then.
Absolutely.
All right.
Okay, so use the DPDT switch to actuate 2 devices at the same voltage. Thank you very much.
Bam.
Keep
We're on the new
forgetting that
one.
I am not alone here.
You are not alone. All right, we're good.
We're actually going to move that up. There we go.
Yeah, it looks good.
Alrighty. So, modify the previous circuit.
God damn it. Dude, you just made me pull it all out.
Amazing. Alright. So, let's see if we can read this without reading the steps. So, we're going from the buzzer, 6-7 to the ground.
With?
Probably blue wire, or the green one.
67 to the ground?
We're using the green one for that,
All right,
yeah.
67 on the ground. I think we're using the green.
That looks like as well 11 to the ground. We were using the purple for that one.
Yep. We ran it right next to it, and I think it was the top 11 on the ground. All right,
Yep,
cool.
right to the ground.
All right, so we're going in reverse order here. We got the grounds in now.
Yeah, actually.
Yeah.
All right, and so next we got to run from the switch to the LED. We're running from the switch 4-3 to 12.
Okay, so yeah, let's go right there. Let's grab 43, which was our DPT switch, and that is the positive on our LED. All right.
We are going to bring 66 to 40. That's another blue.
Yeah, there we go. All right, we're going to go 66 to
Actually, I feel like that was a
40.
yellow.
All right.
40 and 66 was actually a yellow wire.
It was. That's weird. Why? Yeah, whatever. It's not now.
Yeah. All right, so 40 and 66, so 43 and 12. And so now our next two wires, 41 used to go to the 9 volt, but now it's going to be run to the 3 volt along with 44. So we're going to connect 44 and 43 to the 3 volt.
44 and 43?
44 and 43.
Interesting. Okay.
Or 41, I'm sorry. My mistake. 44 and 41.
That makes more sense. Okay, so we got our positive coming in. Let's connect that to the 3 volt as well. 44. So we have our positives coming in from here. They hit here, right? The switch ups then sends it this way. One goes into the positive of our buzzer. The other one goes into the positive of our LED. Then the negative from each one of those go in and complete the circuit down to a ground. That sounds about right.
Yeah, and actually it looks pretty coherent.
All right, so let's turn it on. We should get nothing. We get nothing. And when I push this up, we should be hit. Bam.
There we go.
All right, cool.
How's that LED looking? Was that on?
LED was on, yeah.
Rockin'.
The buzz was a
Rockin'.
bit high. All right, so is that what they wanted us to do again?
Yeah, this is a good place to point out that you can make changes to the voltage of some circuits. This circuit, for example, will work fine when powered by 6 volts. Watch for more notes about power supply voltages.
All right, hold on.
So, yeah,
let me see how. That's pretty high. What happens if we lower the voltage on it? Just out of curiosity. Oh, it goes lower.
Definitely
All right.
does.
All right, ready?
Okay.
All right, we're going 9 volts on it. We're gonna see what happens. Oh,
Ooh, boy, yeah.
Ooh, okay,
boy,
back
yeah.
to 3 volts. 3 volts it is. All right, so the more voltage,
ugly
the higher
noise.
it goes. Gotcha.
So it's actually getting really cool.
Does that mean when you increase the volume on your radio, it uses more electricity?
Definitely.
It has to, right?
It has to. Yeah.
Huh. Never thought about that before. Oh, wait. Is that what an amplifier is? Does it just store more energy and then
How does that work?
does it must store it in like capacitors and then increase the volume, right?
Somehow it allows the more electricity to push through to
It has to be.
outward. Yeah, for sure.
So maybe
That's
it's just
interesting.
capacity. Yeah, I never thought of that. But I mean, it makes sense. I don't
Right.
know. I don't know if it's accurate, but it makes sense.
I mean, if they put in enough of a delay with a resistor, it gives the capacitors a chance to charge up, and then they'll have a bigger volume to draw from.
Yeah, but wouldn't a capacitor just simply drop?
It would just drain it.
Doesn't it just drop it?
Yeah.
Or is that what the timer? Is that what the 555 does? Because that's a timer one. So is that one just drain it instantly and then let it go again?
And maybe they have it on a loop where it stores up.
It stores up and then
And
drops.
so maybe there's just a little bit of lag there.
Yeah, because
That's where you get the feedback from.
I think a capacitor, I don't think it charges up and then can continuously produce the same. I think it just
It just
charges up until it drops it all, which will allow you to store and then drop a
That's
higher
really
current.
interesting.
I don't know. All right, let's keep going. I mean, we can
Still pretty
speculate
cool.
all this all we want.
Still
but
pretty cool.
yeah.
I also am finding it really cool that now I'm looking at this and I'm starting to kind of understand what the heck I'm looking at here.
Okay, cool. three in. We're doing all right.
Right. This is pretty rocking right now. So our next control is going to be for controlling 4 LEDs with the DP/DT switch.
Okay.
All right. And it doesn't tell us to keep our old circuit like it did last time.
Okay.
So
Are
let
we
me
sure?
see. I'm looking. We still are connected from 12
Rip
to
it.
40. We're still connected from 12 to 40.
All right.
We're connected from 12 to 40. We're still connected. We have a connection 41, 44, 41 to default 2. So we have a 41 default 2 that should still be
So we
connected.
have a 12 to 40 or 12 to 43?
12 to 40.
All right. Well, I got to swap it because we went to... Okay, there we go.
Okay, so we're going to start from the beginning.
Yeah, we'll start from the beginning. And I'll keep the 12 to 40 in there. All right.
Alrighty. So, step 1. Push the power switch to off.
I am so glad I did that because I would have felt like such an idiot.
Just pull it all.
I just like, nah, it's all good.
Just rip the droid's parts out.
Yeah.
Connect springs 12 and 40 with a blue wire.
Ta-da.
Excellent.
Yeah, nailed it.
Yeah.
All right.
Foresight. Connect springs 14 and 42. That's another blue wire.
14 and 22. Okay.
Oh, nice. Yeah, it looks like we're controlling 4 LEDs.
Couldn't we just chain it? No. All right. You said spring 22?
Oh, because we're actually the
we are
DP/DT
chaining
switch. The DP/DT switch is actually going to be it's going to be showing us 2 different settings. We're going to be turning it on up for one and down.
All
for
right. You
another
said
set.
14 to 22?
14 to 42.
42. Gotcha. I thought you said 22. I was confused. All right.
Okie doke.
Got it.
14 to 42. Connect spring 16 and 43.
16 and 43. We're going to move this guy over here. You get over there. All right. 16. 43. Got it.
All right. And the last one is going to be 18 to 45. All these with blue wires. But I guess whatever wire helps you keep track
18
of
to
how
45.
it goes, actually.
All right. There we go. I don't think we have a... I don't think it will reach. Yeah, okay.
No.
They're not going to reach. We're using what we got. All right, let's
Absolutely. All right, the next one. Springs 41 and 44 with a white wire.
go. 41 and 44 with the white wire. Okay. 41 and 44 with a white wire. Okay.
Okay. Next is going to be 41 and volt 2.
Actually, I'm moving it to the
Our
other side.
3 volt.
Moving it to the other side.
Yeah, I like doing a little curly Q. It seemed to hold it pretty good.
Yeah, there we go. We'll just keep it that way. That's good. What was the other one?
And then we are now going from 41 to our V2, our 3 volt, with a blue wire, if you'd like.
Gotcha.
If we have any. There's purple right there.
There's
That
purple.
might work.
All right. 3 volt?
Yes.
And you said 41?
41, that is correct.
All right. We got 3 wires in that 41 right now, which kind of makes sense. Because now it's bridging this, isn't it?
Oh, yes, that's what... Okay. Interesting.
Okay. Yeah, let's see how this plays out.
All right, our next... Springs 11 and 13 with a white wire. So it looks like this is both sides of the...
11 and 13.
11 and 13. Oh,
Oh, okay. I see what they're doing here. I gotcha. Okay.
they did end up connecting them when they needed to, looks like. 13 and 15 with a white wire.
13 and 15. Okay.
Interesting.
13 and 15. There we go. Okay.
15 and 17.
Yeah, I've seen that one coming.
Yep.
15 and 17.
And
Okay.
our final is
gonna be
17
ground.
to ground. That's correct.
Yep. 17 to ground? Yeah.
That's
going
correct.
to make sense.
Yep.
All right. So real quick, I just want to review what we did here. So we have our power coming in, right? We've just a single power coming in here to our 43 switch. Our 43 spring here, rather, on the DPDT switch, okay? Then we're also sending power, because it's all coming in here, that power is also going up here, which is automatically going, which is going here, which is going to continue the power. So if we move this up, right, it's going to give power here to there. Oh no, this is going to be constant. It doesn't matter. Power's in, power's going to continue to run here. That's going to go here. Then it goes to our negative. The negative goes here, negative, negative. These all go to the ground. So all we have to do, we're sending power at different points. This is getting power to there, if it's down.
I see,
This is giving power to there. So these are
Okay.
all just daisy chain ground. So there's 4 different points that power would be going to here. If it goes up, I'm predicting already, if it goes up, it's going to light up this and this. And if it goes down, it's going to light these two.
I agree
think
with
that's
you.
what's going to happen.
So our even LEDs are going to light on up or on down. Odd LEDs on up. Well, push the power switch on. When the DPDT switch is down, LEDs 2 and 4 glow.
2 and 4? We messed
Okay.
something up. I got 1 and 2.
All right. Well, what about pushing it up? When the DPDT switch is up, LEDs 1 and 3 glow.
No.
Note that
Well, it should've.
DPDT1 and DPDT2 refer to the 2 halves of the DPDT switch.
I think we messed up something here. 40,
Okay.
40 to 41. Is that actual? Is that supposed to be that?
Let me take a look. You said what was
40
this?
and 41?
It is 41 and... Wait. 41 and 44.
44.
Actually. Ah,
That's what it was.
that's where... Oh, and see, there it is.
There it is. That makes a whole lot more sense.
Look at our LEDs.
Oh, did they? Oh, shit. Turn the power off.
Yeah, look at our LEDs actuating because we're not doing the right thing.
Okay. There it is.
There
I
it
knew.
is.
See, you know what? I'm starting to get better at troubleshooting this shit.
And spotting it.
All right.
early.
So
Yep.
now if we swap it, it's going to go 1-3. Yeah.
1, 3. There it is. This is enlightening.
That's really fucking cool.
This is really cool.
So I kind of want to, like, if you put it on like a 555, like one of the little chips, I wonder if we could get them like the switch.
Oh, that would be really cool.
You know what I mean?
I
Kind
mean,
of
all
like
we'd
a
have to
traffic
do,
signal.
all we'd have to do is just interrupt this signal with
Yeah.
the CPU.
The
Yeah.
little timer. The little timer. The 555s are the little timer ones.
Do you
That's what
remember
it
how
is.
we built that timer earlier that went from one side to the other? This one.
Yeah. See, it's the 555. That's what it is. All right. Let's finish what we're doing here. Otherwise, our ADHDs are gonna send us down some terrible roads.
Okay. All right, our next one is going to control 6 LEDs at 2 voltages with various switches. Keep knocking this book out of sync, so sorry, guys.
You're good.
There we are. Okay. First, we're going to modify the circuit above. So we're not going to destroy
I
it.
didn't rip it.
Yeah, I was
Didn't
about
rip
to
it
get
out
ready
for
and clear
once.
it out. And it looks like we're going to be getting up to 6 LEDs here.
Okay.
So, with various switches.
Okay.
We are going to remove the white wire across strings 41 and 44, the one we troubleshooted with.
Yep. Done.
Connect springs 44 to V3. That's our 4.5 volts for the
Okay.
blue wire.
Blue.
Purple right here if you want.
Yeah. Gonna have to. All right. You said what? 3 volts?
4.5 volts is our
4.5 volts.
V3 section.
V3 4.5 to 44.
Kind of wish they didn't do that to us.
Yeah, I know. It's all good.
We'll just go by the volts, I think.
Yeah. Let's go by
Yeah.
volts. Yeah.
So, next we have connect springs 20 and 4/7 with a blue wire.
20 and 4/7. So 20. Oh, the new ones. We're doing our new guys here. Do we have any more blue wires? We're just gonna start using white.
We are only using 2 whites here, so I think it'll be all right.
Yeah, they're all the little guys.
Yeah.
So, all right, you said 20 and what?
20 and 47.
47. Oh, we're putting on switches. Like a push switch.
Oh,
Okay.
additional switches. Excellent. Oh, yes, I see them.
All right, what's the next thing? I'm assuming
Our next 22 and 49.
22 and 49. Yep, that makes sense.
Excellent.
Okay. 22, 49. So now we have 2 buttons over here. And then I'm assuming we have to bridge these guys. So go ahead, though.
We are going to read off 46 to V2. That's our 3 volt. 46 to 3 volts.
46 to 3 volts.
I think you might be
make
right.
That one half. 3 volts to 46. Trying to do this without ripping all the wires. All right.
We're
good.
What if we just sent power to one of these columns and then attach the blue one to the column?
Oh, we absolutely could do that if you want to do that.
That way we can use our short wires.
Yeah, let's do that.
Sweet.
So,
It's 'cause
actually,
we're learning.
I want the white ones. Let's grab the green.
There's some
Let's
engineers
grab
here.
green. Let's grab this. So we're gonna create a closer little spot so we can tap into these 3 volts. I'm gonna grab this right here.
Excellent.
That's gonna be our 3 volt in. I'm gonna plug this in right next to it, and bam! Now we're sending 3 volts there. Do we want to actually
Hopefully
rewire these guys? Nah, we can keep that one that way.
Yeah.
Yeah, we don't want to mess with it too much, but I think we're good.
I think
we're
we
good
should
here.
be okay. Looks viable.
All right, what we got?
All right, that was just putting
3 volt to 4.6.
Okay, so 4.8 to 4.5 volts.
48 to 4.5 volts.
We're gonna need to make another bridge.
Yeah, let's do the same thing.
Might as well. We're gathering this knowledge. Makes sense to use it.
4.5. We'll drop it down here. Bam, now they're closer. 111. And you said it was 48?
4.8 to 4.5 volts.
Bam. Grabbing the blue. We'll wire this guy underneath. Drop it into the 4.8. Good to go.
Excellent.
All right, cool.
Okie doke.
Should be good. Yeah, I think we're good.
So
All right.
now we have to connect springs 1, 7, and 19 with a white wire, and springs 1, 9, and 2, 1 with a white wire.
Yep. So we're continuing this bridge over here with, we're bridging the ground.
Just like you were suggesting earlier.
Yeah, makes sense.
All right.
Do we have any, I don't get any more whites, but...
And it's interesting how we didn't even have to move the ground because it's all still connected.
Yeah, because you just tap into that same piece of it, right? Because this is all just kind of continuing the ground. It's all going down here to where the main ground is.
All right.
So it all makes sense because they're all running in the same way.
So now
All right.
we push the power switch on. When you push the DP/DT switch up and down, LEDs 1 and 4 will glow, as in the circuit above. At any time, you can also activate LED 5 by pressing S1. You can also activate LED 6 at any time by pressing S2.
All right,
The
you
point
ready?
is that a simple switch circuit provides important flexibility.
All right, so let's turn it on. We have 1 and 3 when it's
We're
up.
still working. Still working. That's
2
good
and
to
4.
know. We had some.
That's how it's supposed to be, right?
That's how it's supposed to be.
All right, now let's see if our little experiment worked. If I press this, 5 should go. It does.
Oh.
I press this, 6 should go.
At any time,
Bam.
too.
Boom, 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 boom.
Oh,
I'm
there
an
it is.
LED DJ, dog.
LED. Excellent.
All right, yeah, sorry. I'm a
Definitely.
child.
Hey. It takes childlike wonder to have
I
good
love
book like
that
this.
we like grabbed a clean board and then this was our other board. Can you imagine if we were still trying to build it onto this board?
I think it would be frustrating.
We ended up somehow building on a clean board that ended up with more wires than
And
our
it's
other
still
board.
it's still chaos. Still chaos.
This is great. Okay, cool. I love it.
Excellent.
All right, are we done?
That is our last for this page.
All right, cool. What are we getting into next? Oh, we're gonna build some more
We're
stuff.
doing switches in parallel and in series. That's going to be interesting.
Okay, cool.
I love in series sort of things.
Bet.
Absolutely.
Awesome. Cool. All right. Well, where's our place? Where's our
Right
book
here.
holder? Okay. Put that
Sorry,
guy in.
sorry, man.
Put that guy in.
Stabbing my wrist here.
All right, cool. We are going to call it for the day. Thank you, everybody that basically watched today. I see that we had some new viewers, which is awesome. Hopefully, you guys had some fun while we fumbled through this. I don't know about you. Honestly, I'm learning a bunch here as we go through this. I don't know. What do you think?
I'm definitely learning a bunch.
Yeah, this is kind of crazy.
When I first looked at this book,
power off.
very important. Very important.
Yeah, no, I mean, when we first looked at it was kind of crazy, right? But I think that, I think this is awesome. I think this is, how we're actually going to continue to be able to pick this up.
It's going to be pretty great.
Yeah, awesome. All right, cool. So we're going to continue this series. We're going to keep going through Workbook 1. The best part is that Workbook 1 is one of 2. So after we finish this, we're going to probably try to continue on to Workbook 2.
And then, who knows, maybe we'll start working on our own projects.
Yeah, I was thinking maybe at the Hackerspace here, we need to get some tester kits and some cool badges. So I was thinking after we finish these workbooks, maybe we start designing, if we actually learned, we start designing our own cool little kits and see if we can get some PCB boards done up and
that
things
would be
like
cool.
that.
Definitely.
I think that'll be a lot of cool.
And especially once we know more about how these circuits run and, what kind of resistors we need, capacitors, where and when, our 555 timer.
I love that we just keep talking about it. The one little.
The one we knew.
The one we knew. We've now learned. This is how we remind ourselves. We just continuously repeat the fact that we figured this out. Hopefully we'll know a little bit more of those as we go forward, as we start to work with them. For anybody that is curious, these are the little microprocessors we were talking about, and the 555 guys are these guys right here that we played around with a little bit earlier that you could still actually find on our initial little tester kit here. So it's cool. All right, but yeah, like I said, we're picking up some stuff. We're going to continue this series. We're going to do it pretty much every Monday. So you can watch us live here on Twitch. On Monday, usually we start around 5 to 5:30. But if you can't catch us on Twitch, you could always just watch us. We upload the videos into YouTube. Just go ahead and navigate over into YouTube and type in BitHaven. And you should be able to find the playlist series. And we're going to continue to build this up. So hopefully you guys enjoy yourself, had some fun. And thank you all for watching as we stumble through this. We really appreciate it. And we look forward to messing around next week and seeing whatever you guys have to bring.
Yeah,
awesome.
Absolutely. It's going to be a lot of fun, guys.
Thanks again.